Hey everyone, welcome to this explainer. If you're a cloud architect, a DBA, or an IT ops pro, you already know the golden rule. Visibility is literally everything in your day-to-day operations. Today we're focusing on an absolutely crucial skill, which is enriching your Oracle Cloud Infrastructure Observability by publishing custom metrics using the OCI SDK. We're going to take a highly practical look at how you can extract exactly what you need from your database and feed it directly into OCI's monitoring service.
Here's our roadmap for today. We're going to cover why custom metrics are an absolute must, check out our flexible deployment options, set up local testing with IntelliJ, deploy to compute instances, and finally resolve any authorization failures. Let's get right to it.
All right, Section 1, why use custom metrics? Basically, we need to fill the gaps in our default monitoring. Let's dive in. When you're moving heavy, critical workloads over to OCI, you've really got to ask yourself, is the out-of-the-box monitoring actually enough for our day-to-day business needs? Sure, the default CPU, memory, and storage metrics are fantastic for knowing the server is breathing. But if you're running complex enterprise apps or specific overnight batch jobs, those basics don't actually tell you if your business is running smoothly.
And that is exactly where custom metrics come into play. We're talking about tailored telemetry that zeroes in on the bespoke, hyper-specific aspects of your databases that default tools are just blind to. You need this deeper insight to monitor overall database health, catch performance anomalies early, and, actually stop downtime before it wreaks havoc on your bottom line.
Think about it like this. What happens if you get a massive spike in blocking sessions? Or maybe a mission-critical financial query is suddenly taking 10 times longer to respond? Default metrics won't see that. Or what about active data guard transport and apply lag? If you don't know about these things instantly, your users are going to start filing support tickets before you even realize there's a problem. So, we've got to use the OCI SDK to extract and publish our own custom telemetry.
Moving right along to Section 2, flexible deployment options, taking this from local development all the way up to the cloud. One of the best things about the OCI ecosystem is the architectural freedom it gives us. We typically see this deployment cycle split into two main methods. First up, the dev environment, where you're running your Java code locally in IntelliJ just to iterate, debug, and validate quickly. Then we have our production environment, where you compile that validated code into a robust jar file and schedule it to run seamlessly via a cron job on a dedicated compute instance. Now here's the crucial pivot between those two environments: security. When you're knocking out code locally on your laptop, you're going to authenticate using your personal OCI API keys. But the second we transition that workload to the cloud, we completely ditch those personal keys. Instead, we use dynamic groups for a way more secure, seamless authentication flow.
Okay, Section 3, local testing with IntelliJ. Let's talk about validating your code before it ever touches production. Before you write or compile a single line of code, you need to check off these prerequisites. Obviously, you need an OCI user account with the Manage Metrics permission and a dedicated database schema user for monitoring. But listen, pay close attention to the network setup. You absolutely must update your VCN subnet security list to allow the database connection to route from your local laptop's IP address. If you skip this step, your code is just going to time out, and you'll be pulling your hair out wondering why. All right, networking is good, permissions are set. Now follow these 4 precise steps. First, configure your IDE's run configuration with your environment variables, things like your API keys and target compartment IDs. Second, update the OCI telemetry API endpoint in your Java code to match your specific home region, say US East Ashburn. Third, update your Gradle build file dependencies. And fourth, just hit run and watch your application validate that telemetry locally. Oh, and a super important pro tip on step 3, if you're borrowing older code snippets from the web, the legacy Oracle JDBC.Oracle driver class is not going to work with this modern setup. You absolutely have to update your build.gradle file to use com.oracle.database.jdbc. Trust me, making that tiny insider swap right now is going to save you hours of annoying troubleshooting. Which brings us to Section 4, deploying to compute instances and moving these custom metrics into a hands-off production environment. So the compute instance has its own checklist, and the biggest architectural shift here is dropping those local API keys for a secure dynamic group. You'll create a dynamic group that inherently includes your compute instance, and then you write an IAM policy giving that exact group explicit permission to manage metrics in your compartment. It's so much cleaner and way more secure, because you're completely eliminating the nightmare of hard-coding sensitive credentials in your production scripts. Wrapping up the deployment is actually a breeze. Just use Gradle and your IDE to build a fat jar file, which is awesome because it beautifully bundles all your dependencies into one neat package. Then, securely copy that jar file right up to your OCI instance via standard SCP. From there, you can execute the Java app right from the command line, or even better, just schedule it in your service cron tab to run automatically on whatever interval your business requires.
Finally, Section 5, Resolving Authorization Failures and Managing OCI Identities Securely. Let's talk about the biggest hurdle you're going to face moving from laptop to cloud, the dreaded authorization failure exception. Luckily, OCI has a really elegant fix for this called Instance Principles. This basically makes the compute instance itself an authorized actor in your cloud environment. OCI completely handles generating, assigning, and securely rotating the security certificates for the instance under the hood. No manual credential distribution, no rotating API keys in production. It is a massive win for both your security posture and your ongoing operational overhead.
So look, if you kick off your jar file on the server and immediately get hit with an authorization exception in your console logs, take a breath. It's almost always just a missing or misconfigured IAM policy. Head back over to the OCI Identity console and double-check that your policy explicitly says your dynamic group can manage metrics in the target compartment. Once that propagates across the network, your app is going to start publishing those custom data points without skipping a beat.
And there you have it. By leveraging the OCI SDK, you've completely bridged the gap between default monitoring and your unique architectural needs. You've built a secure, automated pipeline feeding directly into the OCI monitoring service. So I want to leave you with this final thought. Take a hard look at your complex workloads and your specific SLAs. What other absolutely vital, unmonitored business metrics are hiding deep in your database, just waiting to be uncovered and published?